Onshore drilling, offshore is we use a land rig, drill vertical, and make the well horizontal and direct it towards the sea. So tap the reservoir under the sea. Then there is another application. The next application is offshore multi-well drilling. So offshore multi-well drilling. So let's assume we drill a vertical well, one well drilled, and from that well we can drill one to the right in different directions from single well. So that's the application, or that's the beauty of directional drilling. So from single well, every time you don't have to drill a top section again and again, and then go to the tap the reservoir in different directions. So let's say 70 to 80% part of the earlier drilled well is common for all the wells, and from that point, just above the reservoir, we start going in different direction. So that's uh, multi-well drilling. Then multiple sands from a single well bore. So let's say we have different sands. Why we are talking about sands? Because we are assuming the sand is a reservoir. Now if we drill vertical well and the sands are inclined, we are it is not possible, and we have A, B, C. There are, let's say, 3 4 different types of sand layers which are parallel to each other but separated by a non-porous formation. So between individual sand reservoir, there is a non-porous formation, and which is, let's say, quite thick in width. So what we do is, if we drill a vertical well and the sand beds are inclined, it's not possible to tap all the drill through all 4 sands vertically. So in that case, we drill a horizontal or deviated, not horizontal, but a deviated well, and hit the first sand, then enter to the second sand, and third and fourth. So in single well, we produce from all 4 reservoirs. Now the next application is relief well. I think this one I should explain you at the end. Let's talk about the horizontal well first. What is the horizontal wells, or what is the need of horizontal well? Horizontal well means it's 90 degree to the ground surface. So basically we drill vertical, start building angle in the well, make it 10, 20, 30, 40, 50, 60, 70, 80, 90 degree. So once the well becomes 90 degree, that means it is parallel to the surface. So why do we need horizontal well? Very first reason is, sometimes the reservoirs are very narrow or the thickness is very less. I drilled couple of I drilled couple of reservoirs whose width is, or the thickness of the reservoir was barely 1 meter. You can imagine, barely 1 meter, and the depth of the reservoir was, let's say, 3,000 meters down. So that 1 meter thickness of the bed is lying 3,000 meters below the surface. But it is literally extended in hundreds of kilometers. So you can imagine that reservoir is thin, but literally it is extended in hundreds of kilometers. So you can imagine the amount of oil inside. But try to imagine that if we drill this thin reservoir, we call it a thin reservoir. If we drill vertically through this thin reservoir, how much how much area we're going to get the oil? It's just a 1 meter thickness of the reservoir, and we are penetrating. So that means only from 1 meter of the open spaces, the oil will enter into the well. But if I want to increase the productivity, so that's where the beauty of directional drilling comes in picture. So in that case, we drill horizontal well. So let's talk. I was talking about a vertical well drilling through 1 meter of the reservoir. So we are getting oil only from 1 meter of the open area in the well. Now to increase the production, what we do is we drill vertical well, make the well horizontal, and enter the 1 meter reservoir and stay horizontal inside the reservoir. And that way we drill 1,000, 2,000 meters horizontal. So if I drill 1,000 meters horizontally in 1 meter thickness, 1 meter thick reservoir, and earlier the well was vertical and we were getting oil only from 1 meter of the open space. Now we have 1,000 meters. So that means it's not, you can say technically or exact calculation, but we can say 1,000 times I increase the productivity of the well. So that's the beauty of horizontal well. Or sometimes, like I said, you can see inaccessible location, salt domes, or these cases, or faults. So in these cases, or onshore drilling, offshore. In these cases, we drill vertical, make it horizontal, and hit the reservoir. So that's where the horizontal well comes in picture. Now it's not only, now I gave you example that a reservoir is 1 meter thick. To increase the productivity, we make horizontal well and drill horizontally inside the reservoir 1,000 meters. Now that's where the story does not end. We still increase the productivity. Then we start making lateral one. So let's assume that we drill vertical, we entered horizontal in the 1 meter reservoir, and then same BHA just come little behind, turn to the right, come out of the hole in right direction. Then come, go in the left direction. Left, right, left, right. So this way we make multilateral from single well. Try to imagine a fish bone, how the fish bone looks. In the center, you can see a straight well, the mother bore, and at the side, we drill the lateral. So that profile itself, we call it a fish bone profile. So now you can imagine the amount of productivity I increased in that well. Earlier, it was a vertical well that was drilling vertically in 1 meter of the reservoir, and we were getting oil from 1 meter. Now we drill 1,000 meters horizontal. I increase the productivity 1,000 times. Now, when we drill the laterals, the fish bones, so those were another, let's say 500, 600 meters each. So you can imagine how many thousand times we increase the production. So that's where the direction drilling comes in picture. I understand. I hope you people understand the application of direction drilling by now. At the end, let me know uh, whichever application you missed. So basically, these were the pictures. I was supposed I should have explained you, but just have a look at the pictures. This is the sidetrack how it looks. Uh, I just hope you all can see my mouse. So what happens? Let's take this well. We were drilling we were drilling a well, and then we saw that there is a stuck pipe situation here, and we cannot drill any further, and we cannot pull out also. So whatever fish left here, so what we did is pulled out the upper part of the pipes, pump cement, plug the cement at this part, and then uh, took another bit BHA, directional BHA motor, and reached to this point, and from here we started side tracking, and then we hit the reservoir. Sometimes in this example, it also shows that sometimes because of the misinterpretation or miscalculations, the directional well went outside the reservoir or on the pinch of the reservoir where the production is not possible. So in that case, then again they do some study or offset, compare the offset well log, and if they identify that we hit the pinch of the reservoir, so then they decide, the well site geologist or the geologist sitting in the office, planning geologist. So they replan the well, and then given it to the direction drillers, and then we deviate it according to coordinates and drill it, and we bring it back into the reservoir. So probably they missed to hit the reservoir here also. So we sidetracked the well again. We did not started drilling a new well. We used the well, this much part of the well from the earlier, and from here just ran in hole the pipe under directional BHA, and from here we started deviating and then hit the reservoir. I was talking about inaccessible locations. So look at this. Let's assume this is a city, and we are moving out of the city to avoid any hazardous situation and start drilling vertical, make it horizontal. If this reservoir is small, so uh, Horizontal well is not the profile suggested for this reservoir, so it's a highly deviated well, you can say. This is a salt dome. We usually see you as a geology student, you know that salt dome acts as a cap rock. Further migration of the oil is stopped. So we see these small pockets of the reservoirs, but we never drill vertically. What we do is drill it from the side. Now this is the fault. Instead drilling through this like this, the reservoir maybe some part is also here. So if we start drilling through, we try to stay away from this fault zone. It's not only this line, but the fault zone is affected literally at longer distance also. The cracks are developed longer. Even if I start drilling from here, there are fair chances of my drilling fluid getting lost in the cracks here. So we go away from the fault zone, keep the rig away from that, drill vertical, and then start building angle and hit the reservoir. So the picture itself shows you multiple exploration wells from a single wellbore. From a single wellbore, this is we do it on land also. Instead of making rig move itself cost a lot. It's basically a downtime. We dismantle the rig, we pull out all the pipes after drilling this well, we pull out all the pipes, dismantle the rig, move to another location, start drilling. If the reservoir is big and we continue drilling one well, two well, three well, different wells, multiple wells from a single one. See, I was talking about onshore drilling offshore. So onshore rigs are very cheaper compared to offshore rigs. So we don't use offshore rigs. We use onshore rigs. Drill vertical, start making angle and hit the reservoir. Drill vertical, start making angle and hit the reservoir. So this is a cost saving basically. This is offshore multi-well drilling. So I told you there is a platform here and rig comes close to this platform and there are different slots. So we drill wells from different slots. Here it is shown only one well, but it's not a big diagram. So that's why it looks a single well. Otherwise, multiple slots are available. So those slots, they come and reach to the seabed, the pipes, and through that we send the drill pipes and then drill in different directions. See, this is what I was talking about, multiple sands. If you drill a vertical well, you either hit this reservoir, you'll either hit this reservoir or this reservoir. But if we drill vertical and go horizontal, or go deviated, or go high angle, then there are fair chances of hitting all the reservoirs together. Then this is the last one I wanted to explain you. Horizontal I explained you earlier. So let's assume this is a very thin reservoir, and if we penetrate vertically, we will get oil only from this side. But if I drill vertically and go horizontal, this is 1,000 meters. So I increase the productivity by 1,000 times. Then again, I told you fishbone. What we do is this is the bit. We after reaching the target depth, we move back, then start drilling in this direction. Then come back, then start drilling in this direction. Then come back, then start drilling in this direction. Then come back, then start drilling in this direction. And this, and this, and this, and this. This is called a fishbone profile. It's not shown here, but I explained you with the help of mouse. So with the help of fishbone profile, we increase the productivity multiple times, exponentially. Now coming to the last application of the directional drilling, that is called drilling a relief well. You all might have heard about blowouts. There are two main uh, what should I say? You might have heard about the kick and a blowout. So the difference between kick and blowout is kick is early indication of a blowout. If there is a big pressure difference between the formation pressure and the hydrostatic column of the well, then we see the formation fluid entering the well. Once it starts entering, we get on the surface, we start getting slight indications. There are multiple parameters that with the help of which we can say that this is a kick. So once we start get the kick, so we get the indication and we have to react immediately. to make sure that the reservoir pressure is not entering the well bore. So basically what we do, increase the mud weight. Now, if this pressure goes beyond control, we are not able to control the pressure and the pressure is still rising, rising, rising. You all might have seen the movie Deepwater Horizon. If not, then watch that movie, you'll come to know about this concept. Pressure which is entering into the well and then coming to the surface. How hazardous it is. So, if the pressure is not, if goes beyond control, then that situation is called the blowout situation. The well may catch fire, or you can see, most of the time it catches fire because all we are talking about the oil and gas. So, to now, now let's say this well is on fire. It got a blowout situation here. Now the fire or the temperature is so high and the smoke all around is so much. Forget about the smoke, but the uh, temperature around this place is very high. So it's not possible to go close to this well and shut the well to prevent further loss of oil or gas. So in that case, our directional drilling comes in picture. What we do is go away from here, drill another well vertically, and then go here and hit this well. Why hit this well? Whatever pressure is going here, now we don't have any tap here to close. So what we do is we have to, a perfect well plan is done, and then on the field we have to drill a very perfect well that will that will go and hit this well, and then we start taking pressure in this well. Now we have all the heavy, we have heavy mud to pump. When we are pumping or when we are drilling, we use heavy mud weight, which heavier than the mud weight which was used here. So we use heavy mud to drill this well, and when we go and hit this well, we still start getting the pressure, but we have controls here and we release the pressure in the atmosphere slowly, slowly. At the same time, we keep pumping heavy mud. So because of this, eventually and gradually and eventually, this pressure subsides, and then you see this fire. There is no more fire here because entire pressure is taken in this case, and then they put this, and then once this is, they either put some explosive on the surface and make this part collapse, or they pump cement from the top, and then this well takes over all the control. So this is the relief well. The name itself says that it will relieve the pressure from here and uh, control the blowout. So directional drilling, it's not only about drilling a well. How we come to know how we drill the well and how we come to know uh, that where the well is going, which direction the well is going. Me as a directional driller, how do I know? There are no downhole cameras. Sagar, can you check with guys if they are okay with my explanation?
Yes, sir.
Yes, sir. Okay.
Okay, that's good. So I just hope I'm not going too fast, but it's
No, sir.
okay. So let's continue then. Now, drilling a well, we need a directional tool which is called motor, or the latest technology tool we call it RSS. RSS is called rotary steerable system. RSS tool is something like a computer guided missile. As a directional driller, when I'm on the rig floor, standing on the rig floor, what I do is I do my calculations that which direction I have to go, how many, what degree I need to turn the well, and what degree I need to build the angle in the well, or drop the angle or turn the angle. After doing all those calculations for my next survey, before proceeding further, I do my calculation, and then based on that, I give command from the surface to this tool. This is a very intelligent tool. We call it RSS, and it has got entire electronic package. When I send a command, it receives the command and it keeps doing same thing until unless I change the command next time. So that's the RSS. So let's not talk about the technology here, but what I'm saying is, to drill a directional well, we need a directional motor or RSS. followed by there is a tool which is called. Okay. I think are we good? Hello.
So we can see you, sir.
Okay.
So
I
we
think.
can see the screen.
But did you guys lose anything? Can you see the screen, the PPT?
Yes, sir. Yes, sir.
Direction drilling and LWD, MWD, there is a diagram, right?
Yes, sir.
Yes,
Okay,
sir.
so this was the last you saw, right?
Yes, sir.
Okay, because there was an, I don't know, from somewhere किसी का तो mic on हो गया था and there was noise and even I was not able to hear you guys. So I think we are good to go, right?
Yes, sir.
Yes, sir.
So we have this directional motor or RSS followed by MWD tool. Now this MWD tool is most important tool. Basically, it's, you can call it eye of directional delay, eyes of directional delay. Now why it is eyes of directional delay? There are no cameras downhole. So how we know that which direction this well is going? So this MWD tool, it gives at every connection, we switch off the pump, we stop the circulation for 1 minute, then we start the pump again, and then the tool switch off and then switch on. Once it switch on, it sends the signal to the surface to the logging unit, and there we get the direction and inclination. So what the tool or the bit at present, or the tool, the location of the tool is at what, which direction, and what is the angle in the hole. So this tool sends the data to the surface, and on the rig floor, when I'm standing here, I have a display here on the rig floor screen. There I get to see that, okay, this direction, the bit is here and the angle is here. So now my next, I look at the plan, my next survey, how much it should be, which direction I should go, and what will be the angle in the hole. So based on that, I send the command to the tool, and then the tool steers. Now behind this MWD tool, first we saw the directional drilling tool, MWD tool. Then there are tools which are called the LWD tools. MWD is measurement while drilling, measurement while drilling, and then there is followed by LWD. So LWD are logging while drilling. When logging while drilling means when the drilling is on, the tool is measuring the data, measuring the data from or measuring the rock properties. So that's why it is called logging while drilling. It logs, it records the data while drilling is in process. And there is another which is called wireline. So wireline is once the well is drilled, pull out this whole thing, and then wireline truck will come and they put the tool and they just simply log the well. But why we need LWD in directional BHA? It's because it becomes easier, it becomes easier for the well site geologist to steer the well, or Based on this data continuously MWD is also giving the signal. At the same time, LWD is also giving the signal to the surface. So when I'm getting signal to the surface, or the geologist who is sitting here on the rig, he is also monitoring, or and the data is transmitted through satellite to entire world, wherever we want to send the data, or the client is sitting, or wherever the different parts of the world. My manager in Houston, my manager in Australia, anybody can log in and see the well profile or drilling live. So this, and the geologists who are sitting in the town, they are also monitoring this. So based on this LWD data, if we see that we are deviating away from the reservoir, so looking at the data, if the values goes low, then the geologists, they try to again uh, remodify their geological model, and then ask the directional driller to steer the well in different direction if we are going in opposite direction or some other direction. So basically, a directional BHA contains a motor or RSS, MWD, LWD, drill collar, heavier drill pipe, jar, and then drill pipe to the surface. काय आलं? चालू आहे. कुठे जायचं?
कोणाची ऑर्डर करतो तो पण तुला जाणार आहे उद्या म्हणतो
ठीक आहे, करू order. तो येणार आहे का?
किती वेळाने
झालं थोडं. Sorry guys. So basically, this is a typical directional drilling pattern. Now for drilling a directional well, we need a well planning. What is well planning? A careful planning of directional project prior to commence actual operation is most important. Why the planning is most important? Because you need to consider geology is highly uncertain. You need to take a lot of geological data, offset well data, seismic data. Based on that, the geologists, they make a model, reservoir model, and then based on that, drilling engineers, they plan the well. So drilling engineer in communication with the client plan the well as per the as per client's requirement. The approved plan is sent to field. Like if I am in the field, I have to drill directional well. So the plan is approved by client. Our drilling engineers in the town, they design the well, they send it to the client for approval. Once it is approved, it comes to me on the rig, and then I start implementing, or I start executing the job. So in general, directional wells can be straight wells, deviated or slant wells, S profile well, or and horizontal wells. It's not very difficult to understand these different profiles. So deviated or slant wells. Deviated means it's not a high angle well. We can say 20, 30 degrees. When it goes to more than 40, 50 degrees, then we call it high deviated wells. Then S profile. So let's say we start drilling vertical, then build angle, then again drop angle, then again further drop it. So basically, it makes a S profile. So there are reasons to make these profiles. Maybe there are some obstructions here. Maybe there is a fish here. Maybe there are some complications, or some limitations are there. So because of that, those different profiles are there. Now, a typical directional BHA, what it consists of. When we say BHA, for the first year students, I know it will be difficult for you, but eventually you will come to know once you get into the next semesters, or if you read some stuff online, then you will come to know that what is a directional BHA. What is a BHA basically? BHA is bottom hole assembly. Bottom hole assembly. Assembly is basically, it's a it's a collection. It's different types of strings or pipes or tools. When they come together, it makes an assembly. So that is called bottom hole assembly. Now, what is bottom hole assembly? Bottom hole assembly does not mean the pipe which is coming to the surface, only single pipe. It contains a bit. We'll start from the bottom. Very first thing, we need a bit to drill. Then there's a motor or BSA above the bit, uh, motor or RSS above the bit. And there's a stabilizer. So this profile, this does not mean you're going to see all the directional BHS similar. It may vary, again, I'm telling you, the BHAs vary depending on the well profiles. So, first at the bottom, we have bit, followed by, if you come up and up, then we have this motor, followed by a motor or RSS, then stabilizer, then we have MWD, LWD tools, and Monel. Now, what is this Monel? This MWD tool has got a magnetometer sensor. It has got two sensors. One is gravitometer sensor and the other one is magnetometer sensor, which measures the direction and inclination. Now, the magnetometer sensor is very sensitive. So, whatever is above or below, if it is metallic, steel, not stainless steel, but iron, if it is of steel which is very close to the sensor, then this sensor gives erratic figure because of its magnetism. So what we have this monel. Monel is non-magnetic pipe basically. It looks like an aluminum pipe or steel pipe, but it's basically an alloy. So we put monel above this, and if we see interference from this part of the tool also, then we put a short monel below the MWD. Then after that we have these drill collars, heavier drill pipes, drilling jar, and drill pipe. Now drilling jar. Drilling jar is the most important part in any of the drilling. When whichever BHA goes in the hole for drilling, in that BHA, a jar has to be there. Now, why this jar, or what is the function of this jar? This jar, it helps to release the stuck pipe. If the pipes get stuck, you can jar it, give a jerk to the pipe and pull out the pipes from the stuck pipe situation. But why we can pull out just like that? But no, we cannot. The reason we cannot pull out the string, we cannot continue pulling out or you know pulling the string because there is a tensile strength of the metal. At certain strength, the metal will shear. So we don't pull, give only 40, 30, 40, 50% of the entire BHA weight. We pull weight, what we call. I know you guys won't be able to understand this, but just to understand the jar, we cannot pull the string if it is stuck, but this jar is there. This jar has got a mechanical and hydraulic settings. So what happens, when we see the pipe is stuck, we simply give a over pull to this bottom assembly is not moving because it is stuck. So the piston inside this is under stress, and the hydraulic fluid, it moves from one chamber to another chamber, and the spring releases with a shot. So that jerk, it gives the jerk to the string which got stuck. Basically झटका देता है उसको instead of pulling. So that's the function of jar. And then on the top, we have all the drill pipes which comes all the way to the surface. So this is typical directional BHA. So BHA design also hydraulic calculations are considered while dealing BHA. So that I'll explain you later if I happen to drop into college in future. So there I'll be able to explain you what are the hydraulic calculations, how we do that, how the jar is, what are the weight below jar. So those are things which you really don't need to get into that now. So the direction drilling tools used for drilling a directional well. Soon I'm going to give a lecture in for our chapter, Wadia chapter, SP chapter, and there I will cover this drilling bits. I worked with Smith International for 3-4 years. I was based in Dubai looking after Syria, Iran, Iraq, Jordan, uh, Sri Lanka, and Bangladesh. Ah, so based on that, yeah. So that I'll explain later. But let's talk about the directional drilling tools. So these are the bits. These are different types of bits. I'll just give you an overview. This is insert bit. This is mill tooth bit. This is PDC bit. This is again PDC bit. This is natural diamond bit. These are called impregnated bits. Those are the various types of bits, and there are different applications we use to drill different types of formations. Now there is something called downhole motor. I was talking about the motor. This is very conventional method of drilling a directional well. This is a motor which gives a direction. Basically, you see these lines here. These are the graduations on this motor. Once we set this, and there are degrees written on this part and this part. So let's say 1 2 3 4, 1 2 3 4 is written, so we match 2 to 2 of this and 2 of this by screwing, unscrewing, and then a bend. You will see this from this part onwards, this is not straight, it has some angle, then it becomes a bend. This comes straight, and from here it gives a bend here. So based on the well plan, as a direction driller, my job is to decide what angle I will set on this motor, what kind of bend I am going to set in this motor to achieve the plan, or to achieve the angle or the direction of the well. So on the rig floor, we does this. So basically, this is a mud motor, and this is called this. Why this is called mud motor? Because it is operated using a drilling fluid which is called mud. Now it does not have any electronics. There is nothing inside that. It's just a simple mechanism. Mud passes through this, and you see this spiral rotor, and there is this black lining here. This is stator. So rotor and stator. When the mud passes with high velocity, it spins this rotor. Once this rotor is spin, this bit rotates. Only the bit rotates. So why we need this internal configuration here in directional wells? Because to have an angle in to from vertical, if I want to make a angle, if I want to deviate, I need to either have something which has got a bend. Now let's assume that this motor is has got a bend, so it is straight here, and from here it has got bend, slight bend. So excuse, I'll call you back. करतो कॉल लगेच. थोडा वेळ चालू आहे, एक प्रेझेंटेशन चालू आहे. कॉल करतो. Hold on guys, just give me a minute. So we need to have an angle or a bend in this. So now if we rotate this bend in hole, let's assume this motor is down and we are rotating. So this bend is not pointing in any particular direction. So to give a direction in the well, what we need to do is we do not have to rotate these pipes right from surface to this part, outer pipe, so that this bend will face in particular direction. It will stay in one direction. But how we are going to cut the rock? So to cut the rock, we need to have this bit rotating all the time. So what happens is this outer body remains stationary, but the inner rod rotates because of the mud flow, and it spins the bit. So when the bit spins, it cuts the rock, but the angle remains in the same direction inside the hole. So in that particular direction, the motor continue to go. So that's for try to understand for now. I'll explain you later. Now this is something called RSS tool, rotary steering tool, or rotary steerable system, RSS. RSS, this I'm talking about Schlumberger. Since I worked with Schlumberger, I know other tools also, but Schlumberger has got two different technologies in RSS. One technology which we call push the bit, and the second technology is called the point the bit technology. Now push the bit, what happens when the mud comes from here, you see this pad, it's like a window or a door kind of thing. So the mud, if I want to move this bit in other direction, I will instruct the flow to come out from this pad, or whichever pads comes in this direction. This pad will open, the mud will push this pad outside, and this pad will hit the wall of the well, and the tool will start going in opposite direction. So maybe I can show you later videos and all that in next section, next session. And so that's the reason this is called push the bit. Now this is point the bit. You don't see any pad here. It's only the shaft, and there is a knuckle joint kind of thing here, arrangement. So what happens is, from internal, this shaft, it moves here, here, and accordingly the bit moves here and here. So basically it's something like a frog eye. Frog can move his eyeball in all directions. So it's something like that. So that is called the point the bit. It is pointing in that direction. And this is pushing the string in that direction. And this is pointing the string in that particular direction, whichever direction the bit faces. Now these are the other tools. I was talking about the stabilizers. Stabilizers are of different types, different size. Why do we need a stabilizer in the hole? Because to stabilize or make the string to make the string inside I have to stabilize the string. So that's the function of stabilizer. Acme MWD LWD tools. Now, based how the tool works. Tool has there are principles or different telemetries. We call it a telemetry. Telemetry means, to put it in a simple word, telemetry is the method of generating a signal and sending to the surface. That is the meaning of this telemetry. So there are three different types of telemetries. There are three different types of telemetry: positive pulse, negative pulse, and continuous pulse. So these telemetries, different companies, they have their own pulse telemetry, which generates the pulses and send it to the surface. So this is called the telemetry. So just to make it simple, telemetry is the method or is the technique through which the pulses are generated by the downhole tools and sent to the surface. Now, how the pulses are generated? I told you there are three types: positive, negative, and continuous. So I'll try to make you understand. Positive pulse telemetry. What happens in this? Let's say the pumps are on, I'm pumping the mud, and I see certain pressure, 100 psi pressure. But when this tool is open, I'll see this 100 psi. Let's say the mud is at this. Let's say this is 200 and this is 100 line. So when the tool is open, I see it's 100. But when the tool is closed, then the pressure will rise because it is closed. You see the mud, it is supposed to pass through it, but if you see there is no passage, the passage is blocked. Here the passage is open, here the passage is blocked. So the pressure will increase. So when the pressure is increased, you will see the increased pressure. This is open, this is closed, then open, close. So this basically, this part, it rotates inside the tool. It's like a fan like structure. It rotates, or it's a different combination. I won't be able to explain you, but open, close, open, close, open, close, 1 0 1 0 1 0 binary. So it gives the binary signals, it creates binary signals. But how it creates? Here when it open, the signal drops, and when it is closed, the signal the pressure is high. Signal is low, pressure is pressure is low here, then high, low, high, low. Now this is called positive pulse. Why it is called positive? Because the pressure is from the baseline, pressure is increasing. It's not negative, it's not decreasing. Right? This is the pressure, let's say 100 psi. When the tool is closed, pressure goes to 200, then come back. When the tool is open, then it becomes this is 100. Let's say so close, open. So the tool, it does this function very fast. Tuck, 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 tuck. It's something like that. So that's how the signals are generated and then it is sent to the surface. So this is called positive because the pressure is increasing from baseline. Now you see this is negative. This is called negative pulse. It generates a negative pulse. Let's say the base pressure was 100 psi. Then when the tool is closed, there is a slot or the opening or a valve. It keeps open and close, open and close, open and close. So when the tool is open, when this is open, the pressure is when this is close, the pressure is high. Let's say 200. When it is open, it goes to 100. 200, 100. So close, open, close, open. Because try to understand, when it is open, the mud can pass through easily and there won't be any pressure, back pressure. So the pressure does not increase here. But here the pressure increases because when it shuts. So that's the reason it is called negative pulse. Base pressure was, let's say, 200, then it goes to 100, then again 200, 100. So close, open, close, open, close. So that's how it works. And continuous is, you will always see the baseline of the pressure. It goes in positive, negative, positive, negative, positive, negative. Baseline, let's assume the baseline is here. So when it is on, it goes, and when this is closed and this goes high, when it is open, it goes below the baseline. So this is continuous pulse telemetry. So continuously the pulse is generated. So you can read it, and later on, if you still did not get me, I'll explain you later. Maybe once the lecture starts, I'll be able to explain you. It's very difficult to explain you here, especially for the first year students, because you have not seen the drilling part. Now there was another component called heavyweight drill pipe. What is heavyweight drill pipe? Its outer diameter is similar to the drill pipe, but the tool joints are longer than the drill pipe. So now why we need this heavyweight drill pipe? It's because these pipes are heavier than drill pipes. Now why we need heavier? Because down in the BHA, we need to have some weight. So now, as a layman, everybody will say that we have so many pipes coming to the surface. Let's say 300, 400 pipes, which is coming from the bottom to the surface. So we have so much of weight. No, we never use the top weight. We use weight only which is below the jar. Here, jar and below. This is the lower part. Bit is lower. You put upside. You invert this page. So whatever weight below the jar, we use only these component weight. We don't use the drill pipes which is coming to the surface. There is a reason. If we use the weight which is coming from the pipes above the jar, then I told you that in drilling jar there are pistons and spring. So if I started putting weight from the pipes which is above the jar, then I will, for no reason, I'll keep on pushing or activating the piston. The jar is supposed to be used only when we are stuck. So it's always, whenever we use the weight, we use the weight which is below the jar. So we always keep these heavier drill pipes below the jar. Then there is something drilling jar. I told you these are mechanical and hydromechanical jars. You see there are a lot of videos on YouTube and all that. So you will be able to see the videos and maybe you'll understand how it works. Basically, the basic function of this tool is to release the stuck pipe. Now there is something called drill pipe. We have these drill pipes which comes to the surface. Then this is a different profile we have. This is a comparison. Like we have this profile drilled. You see here inclination and here is the depth. So what we do is, in motor we do sliding. I did not explain you how the motor works, how actually it does, because it's not possible to explain you remotely unless I show you something, or I draw it on the board, or I show you some videos. So basically it's a comparison between, this red line shows the well is drilled. This is basically a well profile, and the red line shows the well is drilled by motor. And the RSS, rotary steerable system, this is the rotary steerable profile, RSS, how smooth the well profile is. And here you see sliding, increase the angle, then rotary, then sliding, increase the angle, then rotary. So the well profile is crooked basically when we drill with motor. And the latest technology tool RSS, when we use it, it's simply drill a smooth well profile. This line is going straight, unlike this undulations. So this is drilled by motor and this is drilled by RSS. So that's the reason RSS, though it is expensive, it is still used in directional drilling because the wells are pretty smooth, the wells are drilled faster, and you get a very good well profile and no sliding, less chances of stuck pipe, and the RSS is rotating all the time, unlike the motors. In motors, we have to stop rotation whenever we want to change the angle in the well, and then only slide, continue slide, and then stop rotation, increase the angle, then again rotate it, then see that you need to increase again, then keep sliding, increase the angle, then rotate it, then rotation again, angle goes down, then again increase sliding, then rotation goes down, increase sliding, rotation goes down. So this is how the crooked well profile is, but here it's very smooth. Now this is um, now this is a Y line log, sorry, LWD log. We have gamma, ROP, density, resistivity. So basically, when I continue drilling, the LWD tool, which is behind the RSS, it records all these parameters: uh, density, gamma, resistivity, porosity, bulk density. So all these parameters are recorded by the tool, which is behind the directional drilling tool. Now this there is called a stethoscope tool. It gives the picture of, basically it gives image of base when it picks the data, when the data is not very dense and we see the resistivity values are not are very high, then we see the dark patches. So based on these values, it creates this image. Now, what exactly happening in this law? Very first thing is ROP, rate of penetration. Now, how as a geologist or as a person, how you will interpret these are the depths. How you will come to know that where is the oil in this part? It's a simple thing. Resistivity. Does water resist heat and electricity? No. So in water you will see the low. However, in oil the resistivity is always high. So if you see, I'll give a small example here. If you see, this is a 0.2 and this is 200. So this is less and this is high. So you see these resistivity values. At this part, it was going like this and then the resistivity started increasing. So it was giving a resistance when the resistivity at that particular depth. So that means there are chances of having oil in this, oil or gas. And in this part, there are chances of having water or a non-oily formation. So again, it becomes like this. Then there are fair chances of having this. The resistivity is increased here. So, similarly, you will see at places this graph is also matching. Actually, the ROP and they sometimes because of the time lapse or something, this shifts up and down. But if you see this peak is matching this, so why? Because this, let's assume this is oil. When there is oil, that means there is a porous formation. When the porous formation is there, we see a rate of penetration higher. So see here, this ROP, this is ROP, sorry, this is gamma, but this is ROP. So you see uh, ROP scale, this is 0 and this is 100. So against this oil patch, you see the rate of penetration also increase because porous formation. So basically they correlate all these log and try to uh, what do we call uh, read the log or understand the formation. Well, we had a very short time and remotely I'm really not very much comfortable because I cannot see you or I cannot hear you people if you understood anything, or if I am going fast, I'm going slow, or if at any point you did not understand, I'm still continuing. But definitely in future, touch wood, if things improves, if we come out of this COVID situation and I get an opportunity to give you a lecture face to face, and it will be much fruitful with videos and very much understanding, and I can have one-on-one interaction. So this is where I conclude, and I can see messages.
Hello guys. If you have any questions, please put your questions here in the chat box. Or you can ask directly on the audio.
Yeah. I don't see any messages if there are. Hmm.
So there is
There's
a
a
question.
look like there's a birthday going on. बर्थडे था क्या किसी का आज? रोहन बोल गए. In the solved down diagram, three rings are shown. So can we use side tracking instead of drilling a different location? I don't know. Let me see. I don't know which three rings you guys are talking.
Rigs. I wanted to say rigs, not rings.
Rigs. Okay, okay, okay. In the solved diagram, three rigs are shown. So can we use side tracking instead of drilling at three different locations? Those are simple example. We use only one well to do the side track usually. Or if it is not possible, then we go for two wells, because it's not, whatever is shown is not exactly that small in the field. The fields are very giant. We have hope, Prajwal, you got the point. Doesn't sidetrack takes time? Yes, sidetrack takes time. Abhijit asked this question, and yes, sidetrack takes time. You need to have patience and a lot of concentration down there, monitoring all the parameters on and on. Any more questions?
Sir, can we retrieve a fish in horizontal well?
Yeah, if you're lucky enough, if the stuck pipe is not severe and you react immediately, very first thing in stuck pipe situation is you should be able to identify the nature of stuck pipe, what type of stuck pipe it is. If it is mechanical, or if it is what do you, pack off, or differential sticking. There are different types of stuck pipe. So if you pick up what type of stuck pipe and react, there are different types of reaction, different types of way you work with that. So if you react it immediately, there are fair chances of releasing the stuck pipe. And if the formation itself is very complicated, then it becomes difficult to release the stuck pipe.
Okay, sir. Thank you, sir.
Yeah, you're welcome. Rohan, it's Rohan's birthday today. Okay, what we have, sir? Can you explain about UBHO, Universal Borehole Orientation? Okay, Gaurav, I hope you can hear me. UBHO, Universal Borehole Orientation. It's basically a sub or a small tool collar in which when we put the probe, MWD probe, we fix with screw. Because if we when the probe go inside the collar, inside the MWD collar, because the pipes, there are fair chances of the probe to start moving inside the pipe, and if the probe moves inside the pipe, then we won't get exact readings. So when the pipe is down there, we have an option. From side there are screws. We put screws inside the collar, and whatever the probe is there inside, the screw enters and touch the probe, and then we tighten the screw. So basically, this UBHO sub, it allows to hold the probe inside the collar. I hope you got that. Good, thank you. If you guys have any questions, we can arrange a session later, or you can write me. My email ID is, I'll share my email ID. Who all
Okay,
can
so
become
if anybody has any more questions,
who all can become a DD, and what next position after DD? See, if there is a if there is a, I don't know how to put it, but yeah, it's the same question arose in my mind when I was there. The question is, who all can become a DD? When I joined the industry, we carried, I did like you guys. I did geology and then did masters of petroleum technology. And then earlier, I've seen there are a lot of people who are doing engineering, and they were easily getting into that. But if you decide, there is nothing impossible. I had a target in my mind that I will get into direction drilling. I will become a DD. So initially I started as a mud logger, and eventually gradually started moving towards the engineering part. Then I got into drill bit engineering, and from there I got into directional drilling. So nothing is impossible. TD reports to his base managers, and immediate reporting person is a company man on the rig. And you ask another question: what next position after DD? After DD, you can become company man or managers or any basically on the rig. Any company man is the biggest position on the rig. So usually most of the DDs, they get into company man. And of course, there is an option to get into base as a managers or as a drilling engineering manager. But then, since it is a matter of it's a question of money. DDs prefer to stay in the field and make money because they are highly paid in the field. Yeah. Any more questions? I don't see any more messages, Sagar. So
hello sir, I'm Namrita from MSc Part 2, and
mhm.
on the behalf of all the students, I would like to thank you for taking out time from your busy schedule and enlightening us. So
Mhm.
thank you so much.
Thank you very much, and it's my great pleasure that, though remotely, but yes, I could share my knowledge. I don't know how much it was fruitful, but I tried my level best. And in future, if we get an opportunity to have a lecture in the college, I'm quite sure that it will be 100% fruitful. Thank you.
Yes, sir, definitely.
Thanks, Sagar. Thanks for all your efforts.
Thank you, sir.
I appreciate.
Also, thank you, Sagar sir, for organizing this session, and all the students who were a part of this. Thank you so much.
Thank you, Sagar. Should I log on?
Yes, sir. Yes. Thank you.
Thank you. Thank you very much. You guys have a wonderful good night and have a safe day.